Hello everyone, and welcome to... Hello?
7 days.
Hello everyone, and welcome to another video on our own devices. I'm Jin Messier, and today we are diving back into the wonderful world of Polaroid to have a look at a product that I've mentioned several times before in previous videos, but really never had a chance to look at in detail. This is Polavision, an instant home movie format released by Polaroid in 1977, and this has become infamous for being a gigantic commercial flop, one which triggered Polaroid's slow but inevitable slide towards bankruptcy. And looking at how this actually works, it's not really hard to see why. From a technical perspective, this is really neat and innovative, but from a marketing and customer experience perspective, this leaves a lot to be desired. And this is really emblematic of Polaroid's unique approach to business, which turned out to be both their greatest strength and their greatest weakness. So without further ado, let's dive into the fascinating and disastrous history of Polavision. So, as I said, Polavision was released to great fanfare in 1977, and this was supposed to be Polaroid's next big technical triumph. This was supposed to do for home movies what integral film and the SX70 camera had done for still photography 5 years earlier. At least that's how company founder and CEO Edwin Land saw it. This was really his pet project, his baby. Other higher-ups in the company, however, were a lot more skeptical, pointing out to Land that, for example, home movies only made up 3% of the total photography market, and that there really wasn't any market research to support a product like this. Nobody actually knew whether consumers actually wanted an instant home movie camera. But Land was undeterred. He believed that, as with previous Polaroid products, the sheer innovativeness of this product would drive consumer demand. So the Polavision system consists of three basic components: the camera, the film cassettes, and the player. So let's have a look at each of these in turn. So the camera, which comes in this lovely leather shoulder bag, is very distinctive with this tall, boxy body and this forward tilted grip. So starting at the bottom, if we remove the wrist strap, we can access the battery compartment. And you do that by lifting this little key, giving it a quarter twist, and out pops a clear plastic holder for 4 AA batteries. Moving up, we have what looks like the grip safety off of a pistol. This is actually a switch to activate the exposure system on the camera, which is driven by this photocell or electric eye above the lens. And the idea was you would squeeze this first to set the exposure before squeezing the front trigger to start the motor and start recording footage. Now, up above the grip here, we have our film indicator, which goes from start to 1/4, 1/2, 3/4 finish, and then finally end or empty. Here we have our viewfinder, and this is of a reflex variety, so it actually looks directly through the lens. And underneath, we have our focusing slider for the viewfinder. Now, interestingly, this actually only works on the viewfinder itself. It doesn't actually adjust the focus of the lens, which I think is an interface design problem. But this thing has a lot more problems with it, which we'll look at in a second. So inside the viewfinder, there are a number of little indicators, including a red lamp that turns on 4 seconds after you squeeze the trigger in order to indicate that recording has begun, as well as 6 seconds before the film cassette runs out. There's also 2 little flags that pop out, one to indicate that the light is too low to properly expose the film, and another to indicate that the light is too bright. Above the viewfinder, we have a battery test button and light. Now, moving up to the lens, you can switch between 2 focus settings, 6 feet to 15 feet or 15 feet to infinity, by moving the lens in and out. And the zoom, which is up to 2 times, is adjusted by twisting the actual barrel. Now, to prevent you from accidentally placing your hand in front of the photocell and affecting the exposure, Polaroid provides you with this little handle for twisting the lens barrel, which you could actually unscrew and thread into the other side to accommodate right or left-handed users. And interestingly, when you switch between the 2 focus settings, there's actually a lighted indicator inside the viewfinder to tell you which one you've selected. That way you don't need to break your sight picture. And finally, we have our film compartment, which opens up by sliding open the switch like that. Now, as we'll see later, Polavision film was relatively insensitive with an ASA of only 40. So you wanted to film outside in very bright light, or if you wanted to film indoors, Polaroid provided this, a 170-watt lighting rig called the Twilight. And this attached to the camera by screwing in this stud into the top. And yeah, this looks really goofy and awkward and like a total kludge, which in a way it actually is. Now, the power cable for this, which unfortunately I don't have an example of, plugs into this jack at the bottom. Now, this is not actually battery powered. You have to plug this into a normal wall outlet. And since that cable is only a couple of meters long, this doesn't give you a great deal of flexibility when filming indoors. Now, when you screw the twilight into the top of the camera, it actually lowers a daylight filter in front of the lens. But if you want to film indoors using lights other than the twilight, what you can do is take the threaded boss from the wrist strap and screw it into the socket at the top, and that will lower the filter out of the way. Now, the Polavision camera took a proprietary instant film cartridge, which formed the heart of the entire Polavision system. So let's have a look at that next. So this contains 40 feet or 12 meters of 8mm film, enough to record 2 minutes and 35 seconds of footage. And once you remove this from the camera, you would then place it in this proprietary tabletop viewer, which would then automatically develop the film and start playing it back to you within 90 seconds, which is very impressive for the late 1970s. That's about as close as you could get to instant replay with film like this. And achieving this capability, especially in color, proved to be a daunting engineering challenge because Polaroid wasn't able to directly adopt the techniques it had used in previous still film formats. Now, as I've covered in my previous videos on Polaroid in greater detail, the original Polaroid pack or roll film in black and white consisted of 3 basic components: an emulsion layer, a receiving layer, and a packet of reagent chemicals. And after you would expose the emulsion layer, you would sandwich it and the receiving layer together and pass the whole thing through a set of rollers, which would pop the reagent packet and spread the reagent between the 2 layers. And what would happen is that this would dissolve the unexposed silver halide crystals on the emulsion layer and cause them to migrate over and be deposited onto the receiving layer, forming a positive image. Once the development process was finished, you would then peel the layers apart, halting the development process and revealing the finished image. Now, color, roll, or pack film worked very similarly, only now there were 3 stacked emulsion layers sensitized to red, green, and blue, as well as 3 dye developer layers in between of the corresponding complementary colors: cyan, magenta, and yellow. And the exposed sections of each color layer would trap the complementary color behind it, but allow the others to migrate past, combining to recreate the colors of the original image. Now, integral film, released in 1972, was also broadly similar, only now you didn't have a separate emulsion layer that would protect the development process from light, which you could remove at the end in order to halt the development process and reveal the final image. You had to accomplish these tasks in a different way. And what Polaroid did was to place a suspension of white titania in the reagent, which is spread between the emulsion and dye layers and the receiving layer. Meanwhile, an acidic layer gradually eats through a plastic timing layer above the receiving layer, eventually reaching and lowering the pH of the reagent, halting the development process. This pH change also turns the white titanium oxide suspension transparent, revealing the developed image. However, neither of these systems was easily adaptable to home movie film. For one thing, Polaroid didn't want to strip away and discard a separate negative layer, while integral film was a subtractive color process only intended for use with reflected rather than transmitted light. So instead, Polaroid turned to an older additive color process known as DufrayColor, which was invented in the 1930s. And this consists of ordinary black and white film stock covered over by a color filter called a réseau, network in French, covered in fine red, green, and blue lines. And so as the light is filtered through this réseau, it will differentially expose the film beneath depending on the color concentration in the scene being captured. And so when light is transmitted back through the developed film and the réseau, it will reassemble the original colors. And this allowed Polaroid to produce 8mm color instant film with far fewer layers than with previous processes. However, this still didn't solve the problem of what to do with the negative layer once the positive image had been transferred to the receiving layer. And like I said, Polaroid didn't want to strip that layer away, nor could they hide the development process and reveal the final image using opaque dyes like in integral film. So what they decided to do was to turn the negative layer invisible, or at least considerably less visible than the positive layer. This was done by using a developing reagent that reduced the exposed silver grains in the negative in situ while dissolving the unexposed grains and causing them to diffuse to the receiving layer. As the dissolved grains on the positive receiving layer covered a larger overall area than the intact grains on the negative, they blocked more light and formed a more visible image. And that is how Polavision instant color movie film works. Now, as we've already covered the camera and the cassettes, let's move on to the third part of the system, this proprietary tabletop player. And this is a really minimalist and fully automated product for the late 1970s. There are actually very few controls on this at all. So if we flip up this door at the top, we see the slot where we put in our film cassette. Forward of this, we have a dial for adjusting the focus of the image on the screen. Underneath, we have another dial for adjusting the vertical position of the image, as well as a red button for ejecting the cartridge. And finally, if we open up our back panel here, we have our power cord, as well as a little compartment that you can open to slide out and replace the projector lamp. And that's it. There's not even a master power switch on this thing. So when you take the cassette out of the camera and pop it into the player for the first time, an optical marker on the film itself is going to be read by a photocell and signal the player to start rewinding the film. And what this does is it strips away a foil cover over a little compartment inside the cassette containing a very thick developing reagent. And this is spread in a thin layer over the film as it passes through a precision molded slot. And once the cassette has been fully rewound, then another optical marker signals the player to pause for a couple of seconds before playing the footage from the beginning. Now, since the reagent is applied from front to back, and the development process takes around 60 seconds, this means that by the time you reach the end of the footage, that film has just finished developing. And this gives you a total turnaround time between the completion of filming to actually viewing that footage of around 90 seconds. As I said, very impressive for the time. Now, when a cassette is rewound for the first time, tension on the film will permanently close a set of electrical contacts, which signals to the player that the film has already been developed. So on subsequent insertions, the player will know not to automatically rewind the film, but rather play it from the beginning. And of course, once it reaches the end, it will automatically rewind it and eject the cassette. Now, on a fresh tape, this little bit of film visible at the bottom will read unexposed, whereas once it has been developed, it will read rerun, like the ones I have here. Now, the light path through this projector is actually quite interesting. So as you can see, the cassette goes in vertically, while the light from the projector lamp goes through sideways through this little prism in the bottom, which bends the light 90 degrees to pass through the film. The image then passes through the rotating shutter for the projector and then through a lens assembly. So this uses a compact Fresnel lens, which I've covered in previous videos, linked in the description, which collimates the light beam, that is, makes the light rays parallel. It then passes through two lenticular grids mounted 90 degrees to one another, which spreads the light out both vertically and horizontally at the precise angle needed so that when the light is bounced off an angled mirror at the back of the projector, it just fills the projection screen. And this system makes very efficient use of light and allows the whole thing to run off a relatively small 140-watt projector bulb. So looking at this on paper, this is a really slick and innovative system. You can really see what Polaroid was going for. Indeed, Edwin Land was forever trying to remove obstacles between photographer and subject to make photography, the creative process, as sleek and intuitive as possible. And so here you have a system where you can finish taking some footage, take your cassette, pop it into this player, and be viewing that same footage within 90 seconds. And you didn't have to adjust any complicated controls. The whole system did it automatically for you. But in reality, however, the system didn't quite work as intended, and let me show you one example. So what just happened there is that this cassette had some damage on the film, and this confused the player's automatic optical sensors and caused the player to enter an endless loop of rewinding and playing the film without actually turning on the projection lamp and showing you any footage. And unfortunately, there's nothing much you as a consumer can do to fix this problem. There are no controls on here to force the film through the projector or turn on the projector lamp independently. If the automation on this fails, you're pretty much screwed. And indeed, I have 6 cassettes here, and only one of them functions properly. That is the only one that plays the footage all the way through from the beginning and then automatically rewinds and ejects itself. All the others stop short after only a couple of seconds and then rewind and eject themselves. So let me actually show you the functioning one. Now, as I said before, it's easy to see why Polaroid would want to make this as automatic and hassle-free a system as possible, but unfortunately, they ended up making it way too automatic, and this does not bode well for this as a consumer product. Now, if that were the only problem with this system, then that might have been solvable in the long term, but spoiler alert, it was far from the only problem. And one of the major downsides of Polavision was the image quality. Like I said before, the film was very insensitive. It was very slow, and this had to do with the presence of both the réseau color filter and the negative layer, which, while far more transparent than the positive layer, still absorbed a considerable amount of light. And this affected the image quality, which reviewers at the time described as murky and muddy. And even though Polaroid had gone to considerable expense to make the lines on the réseau as fine as possible, the color quality of the image was also described as more like the magnified color dots on a television rather than anything natural. And the problems didn't end there. Like I said, these cassettes could only hold 2 minutes and 35 seconds of footage. They couldn't record any sound, and they could only be developed and played back in this proprietary tabletop viewer. You couldn't unspool the film and feed it into any other company's 8mm film projector. Well, I guess you could, but you weren't really supposed to. So all of this made the system far inferior and less flexible than ordinary 8mm home movie systems then on the market. And if that weren't bad enough, say it with me now, it gets even worse because Polavision had the misfortune of being released at the same time as home video formats like Betamax and VHS were just starting to come onto the market. And of course, these formats offered a minimum of 1 hour recording time, actual instant playback, and could be recorded over multiple times. And the emergence of this technology led to the death of the home film camera market and Polavision along with it. And this was such a disaster for Polaroid that they were forced to pull the system from distribution in 1979, only 2 years after they had launched it. And they were forced to write off some $15 million, that's $60 million today, in unreclaimed expenses. And this was made even worse by the fact that in 1974, Polaroid stock had taken such a plunge that it had cost its investors some $4 billion. And Polavision, along with a recent uptick in sales of SX70 cameras and integral film, was supposed to put the company back on track. But obviously that didn't happen. And in the wake of this disaster, Edwin Land was forced to step down as the CEO of the company and eventually retired in 1983. And of course, as I've covered in previous videos, a slew of short-sighted business decisions throughout the 1980s and 90s led to Polaroid eventually declaring bankruptcy in the early 2000s. Now, the fallout from the Polavision disaster extended far beyond Polaroid itself, leading to the collapse of the Austrian camera manufacturer Oymig. Now, in the mid-1970s, Oymig was facing severe competition from Japanese companies, and was convinced by Polaroid to devote most of their production capacity to producing Polavision cameras and viewers. However, when Polavision failed spectacularly, Oymig's revenue stream dried up and the company went bankrupt in 1981. Now, interestingly enough, that's not quite the end of the Polavision story, because in 1984, Samuelson, a British industrial equipment rental company, started offering a specially modified Polavision camera operating at 400 frames per second. And this was to act as an instant check on industrial high-speed cameras. The idea being that you could use this camera to check if your lighting, your camera setup, if everything else was correct before you fed tons of expensive film through your high-speed camera. And in this very niche application, Polavision was able to survive for another couple of years. Polavision also formed the basis for the far more successful Polachrome instant slide stock. This was very similar to the original Polavision film, only it was 35mm and you could actually peel off the negative layer at the end. And so how this worked is that once you were finished exposing a roll of film, you would feed both it and a packet of reagent chemicals into a little hand crank device called an autoprocessor, and you would get very good quality color transparencies within a couple of minutes. And this proved to be very popular and continued to be sold until Polaroid declared bankruptcy in the early 2000s. And that, dear viewers, is the fascinating but tragic tale of Polavision, the innovative but deeply flawed product that sank Polaroid. And this really serves as a cautionary tale about companies becoming blinkered and becoming obsessed with the technical innovation of a product while losing sight of actual market demand. Or, put more eloquently,
yeah, but your scientists were so preoccupied with whether or not they could, they didn't stop to think if they should.
Thank you, Dr. Malcolm. Anyway, that's all I have for you today. Thank you so much for watching, and I'll see you next time in another video where we'll look at yet more fascinating photographic equipment and other devices just like this. Until then, I'm Jean Messier from Our Own Devices. Have a great day.